Today we are going to start Chapter 6, Integration Applications. In this chapter we have 4 lessons. Today we are going to go over 6.1, Area of a region between two curves. So as we learned before, let's go over some warm-up problems. How do we find the area of the region bounded by the graph of y equals 4 minus x squared and the x-axis? So sometimes you have to be able to graph some simple functions like this parabola. So let's have a look. The vertex will be x equals 0, y equals 4. Going down, this is the region we are looking for. So first, the area is from x equals -2 to +2. So integration from -2 to +2, 4 minus x squared dx is the area. As we know, this is above x-axis, so it's always going to be positive. So we don't have to worry about the negative. So this gives us 4x minus x cubed over 3 from -2 to 2. This is 8 minus 8 over 3 minus -8 minus -8 over 3. So it's 2 times 8 minus 8 over 3, which is 3, 2 times 16, is 32 over 3. Let's have a look at example 2. Example 2, find an area bounded by the graphs. Here, y equals -x, 0, and 1. Let's have a look. Y equals x squared plus 2. Y equals -x. X equals 0. And x equals 1. That's a region. So the area is given by from 0 to 1. X squared minus plus 2 minus -x dx. So basically this is top minus bottom. And then you can integrate this yourself. Now let's have a look at more problems. The first one, given these two functions, 2 minus x squared and x, we want to find the area bounded by these two curves because they intersect with each other at 2 points. So first, we are going to solve for the intersections. So system of equations, y equals x. So 2 minus x squared equals x. X squared plus x minus 2 equals 0. Give us x equals 1 and -2. So this is -2. This is 1. Now the area will be given. We are going to write integration from -2 to 1 dx. We are going to integrate along the x direction now. So the inside has to be a function of x. So top minus bottom. The top function, which is 2 minus x squared, and the bottom function, which is x. You can evaluate this yourself. Look at this one. So given sine and cosine function, because they intersect many times, and how do we find the region between this point and this point? So first, we are going to find the intersection between 0 and 2 pi. So when we set sine of x equals cosine of x, as we know, x equals pi over 4 and 5 pi over 4. So the area will be given by integration dx. We are going to integrate along the x direction. Top function, sine of x, minus the bottom function, cosine of x. Sometimes, if we have curves that intersect or more than 2 points, in this case, sometimes the top and bottom will switch. You have to be very careful in this case. For example, given fx equals this and g of x equals this, same thing. First, we set them equal. When we set them equal, we solve for the x value. So x equals 0 and plus minus 2. 0 and -2, +2. Because the top and bottom function switches between different intervals, so we have to integrate separately. So from -2 to 0, top function, which is f of x, minus bottom g of x. And from 0 to 2, the top function will be g of x, and the bottom function f of x. So generally speaking, depends on the problem. Sometimes it will be easier if we integrate along x direction. Sometimes it's easier if we integrate along y direction. So if we integrate along x direction, it will be top minus bottom function. And keep in mind, both top and bottom has to be a function of x in this case. If we integrate along the y direction, then it will be right minus the left, and both functions will be in variable of y. Let's have a look at example 5. Find the area of the region bounded by the graphs x equals this function and x equals y plus 1. So if you look at this function, we are going to integrate along the y direction, because if we integrate along x direction, after this point, the top and bottom function is going to change. So you have to split this integral into two parts if you want to integrate along x direction. So that's why it will be easier if we use dy in this case. So first we write this down. Next, we have to find the boundaries. So with same thing, we set x equals 3 minus y squared and x equals y plus 1. They are equal. We solve for y, so y squared plus y minus 2 equals 0. Y minus 1, y plus 2. So y equals 1 and -2. This is -2 here and +1. So from -2 to +1 has to be right function minus the left. The right function is a parabola. So it's 3 minus y squared. It has to be in term of y minus the left function, y plus 1.